Hi Jared, how are you doing today?
Good.
So today we're going to learn about solving one-step equations.
Okay.
They were the problems that I gave you on Tuesday, so that's going to be kind of what we're doing today.
Okay.
I have a note sheet for you that kind of help you follow along.
Sure.
Do you need a pencil or?
I don't think that would be necessary.
Okay, you got one? Awesome. Alright, so first what we're going to do is review some terms that you may have had in the past. Do you remember what a variable is?
I don't recall.
Okay, so variable, I'm going to show you something. I have this bag here and it's labeled X. A lot of times variables, what they are, they're letters that represent an unknown number, something we don't know. So I have pennies in here. So we don't know how many pennies I have, so we label it X. But if you look in here, there should be one more. We have 3. So in this case, X would equal 3.
Okay.
I'm gonna give you more concrete example. So you may have seen, like in those equations that we were doing,
Yes.
The letter X, that's just a variable. It just represents some unknown number. So like in this case, it equals 3. It could equal 2, 1, any number.
Okay.
Right? So they're usually letters or some type of symbol. So let's put down, start with X, and I want you to write an example down under variable.
Any example, but any...
Break down X.
X.
And then, what do you think? What are some other examples that we might be able to use?
Would pi be... Could pi be an example as well?
Well, pi stands for a specific number. That's a good question. What else do you have? What's the first letter of your name?
J. It could be any letter.
Yeah, so you could do J.
Okay. It could be...
So I'm going to give you a definition right now. So let's say a variable is a symbol.
Do you want me to write this down?
Yeah, definitely. The symbol usually a letter that represents a value or number. Take your time. Awesome. Do you have any questions on what a variable is?
Nope.
No? Alright. So we'll go to our next term down here. It says equation. Remember what an equation is?
Yes.
What do you think it is?
An equation... How can I say? I know what it is, but it's hard to describe what it is.
Okay. Could you give me an example?
Equation like... Let's see. 2 divided by 12.
2 divided by 12. Okay. That's part of it. So with equations, there are always 2 math statements that are equal to each other. So for instance, you could have 3 plus 7 equals 10, alright? And they're equal to each other. So what I like to think of it as, each side is like a balance scale. So draw 2 lines and that creates a balance. I'm not the best artist, but that's my balance scale. So each side should always be equal to each other. I'll give you an exact definition. I want you to write it down right there. Equation. Say there are two statements or math expressions that are equal to each other. Do you have any questions? So sometimes equations can have variables in them. So for instance, we could do, say, x plus 2 equals 7. That's an equation. Only we have that variable, and we don't know what that value is. So it's kind of like those problems I gave you on Tuesday.
Right.
So you're trying to figure out, we're going to be trying to figure out what x is going to be equal to. So can you give an example? Equation?
I'm trying to think about the problem.
Take your time. While you're thinking, I'm gonna set up the video. Get it done. Make sure it's running. You got it? What do you think?
X. 5. Well, I don't know what's 5.
Like,
19. Awesome. That's a perfect example. Alright, so let's watch this video on what we just talked about a little bit so you get a little better idea. Hopefully this sounds not too much. Can you hear that?
Very simple equations that we call one-step equations. When I started teaching, my students were pretty good in middle school, and they were able to measure angles, calculate the area of a problem. But when I put this on the board, they had 3. And I could never really figure out why. It's just a variable. And a simple definition for a variable is a letter that represents an unknown value. X or Y or A or B. And these variables, well, they're just mysteries. They're just puzzles. And when you see an equation like this, you should really start thinking about it like a sentence like this. When you see that sentence, you've already solved the problem. Your brain just does it automatically. It's something you like to do. It's something you'll do naturally. So here, we have to make these x's seem a bit more friendly. And, well, maybe we're getting ahead of ourselves a little bit. Let's take a look at a really easy equation. So what does this mean? What are those 2 little lines in the middle trying to tell me? Well, historically, people have thought about equations like balance scales. You can see one over here. When the 2 sides are the same, it's green. When weight is added to one of the platforms, the scale turns red, indicating that the equation is unbalanced. When you move that weight, it goes back to being in equilibrium. So let's take a look back at our equation over here. 3 plus 3 equals 6. The first part of that equation is 3 plus 3. So let's go ahead and model that on our scale. You can see the scales become unbalanced. We have to finish the equation to make it balance. On the right-hand side, we have 6. So let's go ahead and place a 6 on the right-hand side of our scale. And you can see they balance each other out. 3 and 3 is 6. They're the same. But we're actually saying something a bit bigger here. See, that's 6 on the right-hand side. That's not really a 6. that 6 is actually 6 little 1 blocks. And the 3 blocks on the left, each of those blocks is actually worth 3 1 blocks. So instead of thinking about it as adding 2 3s and getting 6, you can think of it as combining 2 sets of 1s. So what this equation is really telling you is that 3 1s plus 3 1s equals 6 1s. This may seem kind of trivial, but remembering integers as groups of 1s is really helpful for algebra. And that is the mystery of x. We're trying to find out how many 1s are inside that x because it's different in every problem. It might be 1 in one problem, the next problem x might have 3 1s inside of it, and the next problem x might have, well, a bunch of 1s in it. So that's sort of what we're trying to figure out, how many 1s are in x. So let's look at this really easy algebra.
We're going to stop
You might be able
there. Go back to it. So, I made balance scales. Again, I'm not the best artist. So, think of an equation as kind of like a balance scale. So I put the equal sign in the middle. And then on each side is going to be our math expression. So, like before, when we talked about x plus 2 equals 7, we would put x plus 2 on this side and 7 on this side.
Okay.
And I'll show you, I made counters for you, like the blocks I think you were seeing. And then I also have balloons,
Okay.
but you'll see what they'll come into play later. So I have a variable in x. I didn't have an extra bag, so I kind of made my own. So that would be our variable. So let's say on one side of the scale, I put 3 of these plus 1 blocks. So each box is worth 1. The scale is going to go like this, right?
Right.
Because it's going to be heavier on this side. So to balance this out, we would have to add 3 blocks on the other side. 1, 2, 3. So that would balance it out. Alright. So what do you think? I want you to set this up on yours. We'll put 2 blocks on one side. What do you think's going to happen? Right, exactly. So what are we going to have to do to balance it over to the side? Awesome. Right, just add 2 both sides. Ugh. Balance there. Excellent. So now we're going to go into actually solving for equations. I'm going to start with addition. So equations where you see x plus something. Right. Here.
We'll do this in your head. But let's examine some of the concepts at play here. We'll start by modeling on the scale. We have 1x and 3 1s on one side. And on the other side, we have 7 1s. So to solve this, what I might do is try taking 1 from each side at a time. I'll take 1 from both sides, and it's still in balance. I take the same thing from both sides again, it's still in balance. I'll try that one more time, and I'm still in balance. Now look what the scale is telling us. 1x is 4 1s. X equals 4. And how do we get that? Well, we subtracted 3 from both sides. Let's take a look at the numbers. See, what we did was we subtracted 3 from both sides, effectively canceling out the plus 3 on the left, and that left us with x equals 4. So algebra is sort of the process of removing clutter from the side with x. I want to make this equation tell me what x equals, and the way I do that is by removing the plus 3 by subtracting it from both sides. This is the basic process of solving algebraic equations, getting x isolated on one side. Okay, here's another equation. x plus 8 equals 16. I want to deal with that plus 8. So we're going to deal with it by removing 8 from both sides. Get x equals 8. Okay? Pretty simple. Let's take a look at a different kind.
Alright. So if you can see in your note packet, for example, what? See that down here?
Yes.
Excuse me. It's x plus 2 equals 7. That's going to be the first equation that we're going to try to solve. So I want to first start with modeling it on our schedules.
Okay.
So I'm going to take our variable, and I want you to do this along with me. So we have x plus 2. So we'll put our x on one side, along with 2, since we're adding 2 to x. And then it's going to equal 5, or 7, excuse me. So we're going to put 7 blocks on the other side. Awesome. Looks good. So now they're equal. They're balanced. So like in the video, what we have to do is we got to get x by ourselves. That's our goal, because that's what we're solving for. So we got to take away one block. And when we take away one block, it's going to make it unbalanced because we just removed something. So this is going to be heavier. So whatever we do to one side, we got to do the other side to keep it balanced. So I'm going to take away 1 from this side. Alright, so now it's balanced again. But we still have another 1 on this side. So we take away another 1. And then whatever we do to one side, we got to do the other. So from there, now we have x. We know it's equal to, there's 5 blocks there, so we know x is equal to 5. Now I'm going to write it out on the board so you can kind of see more of the math. So what we did when we took away 2 blocks is that we were basically just subtracting. So we subtracted 2 on this side, and we subtracted 2 on that side. And then what we were left with is x plus 2 minus 2 is just x, and then 7 minus 2 is 5. Alright, so I want you to write that in your notes, just as like a reminder. And that's kind of the work I want you to show, so I can see that you understand the concept. Any questions so far?
Nope.
Now, you can always check your answer too. So if you're not sure, like I don't know if that's right, what you can do is you can plug in what you got for x back into the original equation. So we got x plus 2 equals 7, and I'll plug in 5 for x. And we know that 5 plus 2 is 7. So we can just say, I usually put a check just to show it. So we know it works out. So that's something you can use if you're not sure, just to check your work. Right, so let's try one. Or not on your own yet. We're going to try one together. So the next one, you can see example 2 says x plus 4 equals 8. So how do you think we would set up this equation?
1 blocks.
Right. And we got to have our variable.
And dates.
Awesome. Looks good. So what do you think our next step would be?
We're going to take 4 each. Take 4 from each side.
Right.
We'll have 4.
Right. So x equals 4. Excellent. Now let's try writing it out on the the board. Sometimes doing it that way, writing it out on the board, is a little more confusing. But, so what do you think we would do?
Take 4 each side.
Right. Just to
Subtract 4 from each side. Yeah.
X equals what? 4. Exactly. I think you got it. Yeah. So if you go to the next page, I want you to try one on your own, and you can use these if you want to. If you feel that you don't need them,
Okay.
that's perfectly fine. You can try it on your own, and then we'll go over in a little bit.
What do you call people say that they missing they check boards I know
If
they
you have any questions, just let me know. This is practice, so don't be afraid to make a mistake. We learn from our mistakes, so.
You want me to continue on to the subtraction?
No, did you finish it?
Yeah, I already finished it.
Okay, awesome. Let me see, what did you get? Is
I
it?
got 5.
All right, awesome. You did excellent. Good job. All right. So now we're going to move on to problems dealing where in the equation we're subtracting from x.
Okay.
So I'm going to play the video again. He's going to show you how to
X
subtract.
minus 2 equals 3. Okay, this is going to be a little different. Well, let's head on over to the scale and start modeling. So we've got an X in there on the left-hand side. Then we have that minus 2. How are we going to deal with negative numbers? Negative 2. I mean, you know that ones way down the side that they end up on. Maybe negative ones lift up the side. And actually, we can model that using these 2 negative 1 balloons. The scale is still unbalanced because we haven't completed the equation. On the right-hand side, we have 3 ones. There, now we're balanced. But what are we going to do with those negative 1 balloons? Okay. Actually, believe it or not, a negative 1 balloon can be popped by a 1 block if you throw it at it just right. They actually meet and cancel each other out. So let's add another 1 to that side. Okay, but now we're unbalanced because we removed those 2 negative 1 balloons that were lifting us up. Now we did this before, but we didn't explicitly mention it. It's an old rule for equations. What you do to one side, you must do to the other. So taking a look back at this scale, we added 2 1s to the left side. We're going to have to add 2 1s to the right side. And look at what the equation is telling us. X equals 5. Alright, so if we go back to the math on the board here, the item to clear from the X side is the negative 2. And I can do that by adding 2 to cancel it out. So I have X equals 5. Deal with another one. We have X minus 5. And deal with that negative 5 by adding 5 to both sides. And that tells me that X equals 6. Alright, let's take a look at another type. Here we have 3x equals 9.
We're going to stop there. Alright, so this is where the balloons come into play. So if we place 2 balloons on one side, what do you think is going to happen?
It would raise the scale.
Right, so if you think of balloons that float, so it kind of raise the scale. So what we could do to balance it, we could either put 2 balloons on the other side to raise it, or we can pop them with the 1 blocks and it kind of cancels them out. Okay? So let's try a problem. And this one's going to be example 4 in your notes. So I have it written on the board. X minus 2 equals 4. So we'll set it up again. You'll put your variable, and then since it's minus, we'll put the 2 balloons. And that's going to equal 4. So we get 4 1 blocks. Got it all set up. Alright, so in this case, what we gotta do to get rid of these balloons is we gotta pop them with 1 blocks. So if we put 2 on this side, we gotta put 2 on the other side. So what we're left with is x equals 6. So showing them on the board is we added 2 1 blocks on each side. We're left with just x. And when we added 4 plus 2, we got 6. Any questions about it? But, alright, so let's try one together. So the next one is going to be example 5, which is x minus 4 equals 3. So put x on one side, and then we need 4 balloons, since we're subtracting from it. And how many, what do we need to put on the other side? 3 1 blocks. So we got x minus 4 equals 3. What do you think we need to do to get x by itself? Okay, we're not subtracting, we're actually going, you're right, we're going to add 4 1 blocks. I think you knew what you were doing, I just, so, yes, you're right, we're going to add 4 1 blocks. And that will take away the balloons. But now it's unbalanced, so whatever we do to one side, we're going to do to the other. So what would we do to this side? Yeah, we would add the 4 blocks. And what would our final answer be? What did you get? 8. Okay. I think you added 1 too many. So we started out with 3, so let's back up a bit. So we took those off. We added 4 to this side, so we gotta add 4 blocks. So after you added the 4, we had 3, and then we added 4. We're left with 7. So let's try one on our own, and it's going to be example 6, the x minus 3 equals 5. And again, you can use the scale if you want to. If you don't want to, feel free. Oh, you know what? I didn't write it out for you, that last one. Would you like me to write it out, or do you feel comfortable? Okay, awesome.
Which sentence uses the word step?
Awesome. Could I see you write it out? You're absolutely right. Awesome. That looks good. Alright. So, we're going to take a pause on the packet and I want to give you another sheet just to kind of summarize what we did so far. We don't need this. So here's a chart, and on the left side it gives you examples of equations, different types of equations. So here's one with addition, and we're adding is where we're adding to x. And then the next one is subtraction, where we're subtracting from x. The other two, that'll be for a different lesson. We'll get to multiplication and division later on, but not today. So on the right side, we're trying to figure out what operation, meaning plus or minus, we need to use to get x by itself. So what would we have to do here to get x by itself?
We would have to subtract.
Subtract. So just put a minus sign. You got it. Alright, so you can hold on to that for when we do multiplication and division. So let's go back to our guided note packet. And it's important when we learn different concepts that we can think about how it can be useful in our lives.
Okay.
So what I want you to do on your own, I want you to think of some ideas of how you think these could be used. And we'll discuss about it. So I'll give you just a couple minutes. Feel free to write down your ideas. And then we'll just share what we came up with. Alright, so where's
I said that it can be used for physicists to understand physics.
Oh yeah, definitely. Definitely working physics. Also a lot of problems with money.
Mm-hmm.
You could use, so let's say you put so much money in the bank and you want to figure out, well, how much did I have at the beginning? You could check using that. So I have a couple examples written down, and we're not going to focus on solving these types yet. They'll come later word problems, but I just want to show you how this can be used in real life. So it says, let's say you put $20 in the bank and you now have $80 in the bank, but you want to know what you started with because you want to make sure there's always at least $50 in your bank. What is the amount you started with? So what we would do is that X is going to represent how much we started with. And then we're going to put $20 in the bank. So I'm going to put 2 blocks. And this time, we're just going to pretend like instead of +1 blocks, it's going to be +10. And then we know we now have $80. So we'll put 8 blocks. Six, not a balloon. 6, 8. Alright, so then we got our equation set up. What we do, we take off 2 blocks from each side. We're left with 6, but since they're each 10, it would be 660. Now the second one, this deals with more zoology. It says, let's say a shark eats 5 pounds of food, and now there's only 3 pounds in the tank. But you want to know how much the zookeeper on the previous ship fed the shark. How much food did the previous zookeeper feed the shark? So what we would do is we would take our variable, and that's going to be how much the zookeeper originally fed. And this is with subtraction. So we'll add 5 balloons. for 5 pounds. And then we know there's only 3 left. Put 3 1 blocks. So what we gotta do is we gotta add 5 1 blocks to the side to get rid of the balloons. 2, 3, 4, 5. Now I take them away.
Yeah. He's gonna need to put the glass.
Okay. Alright, so we wrap it up. And what we're left with. Do you have any questions on that? Real quick. Just want you to try some of these. Is that okay?
Yeah.
And you can use this if you want to. Make sure you show your work.
Let's just
Okay.
let's just use the ones for exactly.
Finish? Awesome. Thank you, Jerry. Thank you for helping me out.
Good.